Hello, this is Jack Jackson. Today we're going to be looking at linear inequalities in two variables. So basically we're going to mainly be looking at how to graph the solution set to these. So let's start by looking at just a very simple inequality, x is less than 4. Now, if you think of this as an inequality in one variable, then the solution set is a set of real numbers that can be graphed on a number line. It's the interval from negative infinity to 4. Or in other words, a set of all x's such that x is less than 4. And so you can see that on the number line going forever left up to, but not including, 4. But we could also think of the set of points in a plane for which x is less than 4. So you start with all points in the plane, and then when you put this restriction that x is less than 4, we eliminate the x's that are great. We eliminate all points whose x values are greater than or equal to 4. So we can think of it as a set of ordered pairs, x, y, such that x is less than 4. Now the boundary line is going to be where x equals 4. It's not included, so it's graphed as a dotted line. And then we shade the half plane where of all the points where x is less than 4. So you can see that graphed here. More generally, if we have any kind of linear inequality in two variables, graph the y equals, or replace the less than or greater than or less than or equal to or greater than or equal to, whichever one of those you have, replace it with an equal to, and that will be the boundary line. Of course, if the equal to case is included, then that will be a solid boundary line. But whereas if it's a strict inequality, a strictly greater than or strictly less than, then that boundary line will be graphed as a dotted line because points on that line do not make the inequality true. And then what you're going to have is half of the plane, one side of the line is going to be shaded. So for example, if we were going to graph y is greater than 3x plus 1 and think of that as a set of ordered pairs x, y, such that y is greater than 3x plus 1, we first graph the boundary line y equals 3x plus 1, and let's see, notice that goes through 0 and 1 here, and every time you go the right one you go up 3, and so we get this dotted line here for the boundary line, and notice we want y's that are above that line, and so we shade this here. So notice if you plug in 0, 0, it will make this false. 3 times 0 plus 1 is 1, and the other side is 0. 0 greater than 1, that's false. So 0, 0 should be erased. In fact, this entire side then is erased. And if we try something that does work, let's see, something that should work should be like negative 1, 0. So 3 times negative 1 is negative 3 plus 1 is negative 2. 0 greater than negative 2. Yep, that's true. So that point should be a solid point, and see it is. In fact, all these points over here are solid. So we can basically look at sort of two methods, pretty much the same thing, but slight difference here. Solve the inequality in the form with y by itself on the left. Graph the boundary line as a solid or dashed line as needed. Solid line if the or equal to is included. If it doesn't have the or equal to part, then it's a dotted line or dashed. If it's less than or equal to, shade the part of the plane below the boundary line, and if it's greater than or equal to, shade the part of the plane above the boundary line. But be sure you've got y on the left side to see this. Another way to do this, maybe even better in some ways, is to again graph the boundary line solid or dashed as needed, in the same way that you did for method 1, but this time to decide which side of the line you're going to graph, all you have to do is do a test point. You need to test a point that's not on the boundary curve. So if 0, 0 is not on the boundary curve, that's usually the easiest thing to evaluate at, so that's usually what I use for a test point. So if 0, 0 is on the boundary point, other good points might be 1, 0 or 0, 1, or you can really use any point you want. The point here is just to try to pick the easiest points to evaluate that you can use. If the test point makes the inequality true, then shade that point and then all the points on that side of the boundary line. If it makes it false, then you erase that point and erase all the points on that side of the boundary line. And of course, you'll shade the other side. So let's see if you can do this one. Get a piece of graph paper out and graph the solutions to 3x minus 2y is greater than or equal to 5. Press pause and come back when you're ready. So first we graph this. We can use it either way. So we can graph this equation in a couple of different ways. We can just simply find any 2 points, since we know the boundary line is a straight line. Pick any x and find the y that goes with it, and do this for 2 points, get your straight edge out, and boom, you got your line there. We can also solve for y, and we see that in the slope y-intercept form, or just slope-intercept form, we have the boundary line as y equals 3/2 x minus 5/2. So it goes through the y-axis at 0, negative 2.5, and it goes up 1.5 each time we go to the right. So notice that puts it through the point 1, negative 1. And see, plug that in. 1, negative 1 would be 3 times 1 minus 2 times negative 1 is 3 plus 2 is 5. That's actually true in this case because the equal to part is on the line, and that is included in the solution set. So notice we graph with a solid line here. And let's see, from there, if we want another one with integer values, we could go up 3 when we go to the right 2. So here we are at the point 1, negative 1, and we go right 2 and up 3. We should be at the point here 3, 2. Let's check it out. 3 times 3 is 9. Negative 2 times 2 is negative 4. 9 minus 4, that is 5. So that's on the boundary line. Now, which side do we shade in? Well, if you put it in this form where it's y, solve for y, and notice how we did that. We subtracted 3x from both sides. When I divided both sides by negative 2, the greater than became a less than, so it's less than or equal to actually. So y is less than or equal to 3/2 x minus 5/2. So y is less than or equal to, the or equal to means we have the solid boundary line, and the less than means we shade below, straight down from that line. So we're shading all of this region. Another way to do it is to just test a point. So notice I try the 0, 0 is not on the boundary line, so I test that, and you can see it worked out here on the right. 3 times 0 minus 2 times 0 is 0. 0 greater than 5 is false, so we erase the origin, which means we erase this entire side over here, and which includes all of the second quadrant, for example. We erase that, and a little triangle out of the fourth quadrant and these other regions here. And what's left is we shade over here. So after completing this lecture, you should be able to graph the solution set for a linear inequality.